Hello, kiddos. Today we are going to talk about the angle outside of a triangle. It's called the exterior angle of a triangle theorem. Honestly, this is a lot like the last video where there's one rule. So in the last video, the one rule was the three angles in a triangle add up to 180. Do with that what you will based on what you're given, but all you really needed to know last time is that the three angles in a triangle add up to 180. We're going to come to a very similar conclusion in this where there's one rule and then you just do with it what you need to. So if we look at this opening exercise right here, and it says find the value of x. Well, I have 32 and 38 inside the triangle, and I have this x outside the triangle. I don't know what the x is, but you know what? I think I can figure this thing out. Because if the three angles inside a triangle add up to 180, also known as the triangle angle sum theorem, I can say, well, 32 plus 38 is 70, and 180 minus 70 is 110. So this angle right here is 110, and then the 110 and the x form a line, so those are a linear pair. Linear pairs are supplementary, so 110 plus x has to be 180, meaning x has to be 70. Wait a second, I already said 70 once. Where did I get 70 before? Oh, the 70 was right here. That is not a coincidence. That is something that happens every time. The sum of these two angles right here adds up to the angle on the outside. And that is what's known as the exterior angle of a triangle theorem. So I'm actually going to jump a little bit. I'm going to jump down here to the rule. The rule is when you have an angle on the outside of a triangle, this angle D right here, that's the exterior, it is equal to the sum of the two remote interiors, A and B. What I want you to do on your paper right now is exactly what I'm going to draw. This is a nice reminder of how the theorem works. These two things here add up and equal that thing right there. Okay, so A plus B equals D. Now, I'm going to go back here, and this is what's called a proof of the theorem, where we say, well, let's pretend I don't have any numbers, because if I have numbers, it might just be a coincidence. So let's drop all the numbers and see if I can show why this works every time. As I go through this proof, you really should be following along. I do not expect that you could do this middle part on your own. Okay, this is not one of those things that you should be able to figure out all by yourself. This is something that I need you to understand as I explain it. So in this picture right here, what's one of the things that I know? Well, I know that 1 plus 2 plus 3, those are three angles inside the triangle. And the three angles inside a triangle add up to 180. Why do we know it? That's what's called the triangle angle sum theorem. And if you can't remember the phrase triangle angle sum theorem, you could just write in there, the angles of a triangle add up to 180. That's okay, cool. All right, what else do we know? 3 plus 4. Well, 3 is right here. 4 is right there. And those two form a line. Oh, those need to add up to 180 also, because linear pairs add to 180. That's another thing that we know. Now, here's the new thing. If you have two things that both equal 180, then that means those two things equal each other. So that's what I'm going to write next. If 1 plus 2 plus 3 equals 180, and 3 plus 4 equals 180, then 1 plus 2 plus 3 equals 3 plus 4. And that's a new fancy thing that we're going to do called substitution. And substitution is the idea that if two things equal the same thing, then they equal each other, and you can just swap them in and out. Okay? So that is called substitution. And then, last but not least, in this equality, 1 plus 2 plus 3 equals 3 plus 4. I have a 3 on both sides. So what I can do is I can subtract 3 from both sides, and the equation would still be balanced. and we did what's called the subtraction property. Again, a new thing. I'm putting anything in blue that's new. And then I end up with 1 plus 2 equals 4. And if we look back on the diagram, 1 plus 2 equals 4. That's the theorem I just showed you down here, that the 2 on the inside add up to the 1 on the outside. Okay, so now let's just do a couple examples. So turn the page with me. Bloop. And if we turn this page here, it says set up an appropriate equation to solve for x. Find the measures of the remote interior angles and the exterior angle. Okay. Well, I'm looking at this picture. I'm realizing I have 2 angles on the inside and 1 on the outside. And the rule is the sum of these 2 equals this one. And I want you to circle that and put the plus and put the equals out there, all of that. I want it all on your paper because that visual cue is going to remind you of the rule. So 6x plus 2 plus 8x minus 4 equals 13x plus 6. And now I just need to solve for x. So 6x and 8x is 14x. Plus 2 minus 4 is really minus 2. And let's see, I want to subtract the smaller amount of x's. So I'm going to subtract 13x from both sides. So 14 minus 13 is 1x, or really just x. Minus 2 equals, why did I write 8? I got ahead of myself, equals 6. And then when I add 2, I'm going to get 8. Okay. Sweet. So x equals 8. Now let me make sure that I do everything it said. It said solve for x. Done. Then it says find the measure of the remote interiors and the exterior. Okay, so I have to do that. These, by the way, just as a reminder, I said it once, but very quickly. These are the remote interiors. This is the exterior. And if I want to find their measures, I just have to plug an 8. So I'm going to plug an 8 here. 6 times 8 plus 2. That's going to be 50. And then over here, 8 times 8 plus, minus 4. That's going to be 60. And I'll plug an 8 here. 13 times 8 plus 6. Well, 13 times 8 is 104. Plus 6 is 110. And now I've done what they said. Okay. I forgot to set a timer to see how many minutes in I am, but here's what I want you to know. However many minutes that is, there is one big idea you need to know. And that big idea is that these 2 angles on the inside add up to the angle on the outside. Okay? That's what we're doing every time. So let's jump down here and do it again. In triangle ABC, the measure of B is 3 times as big as A. The exterior angle at C is 140. Find the measure of A. I don't know what to do with that because I don't have a picture. Okay, so I need to draw a triangle, just like we're used to, and extend this because it mentioned an exterior angle, so I know I need to extend one of the sides. All right, in triangle ABC, I don't know where I want to put A, B, and C yet. B is 3 times A, and exterior angle at C. So that tells me that this point right here has to be C, and that A and B can be either one of these 2. I wrote it like that. You could have done it the other way. Doesn't really matter. Okay, now it says, let me go back. The measure of B is 3 times A. So A is going to be X, and B is going to be 3X. And the exterior angle at C, so the one on the outside here, is 140. Now it looks like a picture that we're used to having. So now we're going to do the rule that I told you we had to do. These 2 here have to add up to equal this thing on the outside. X plus 3x equals 140. That means 4x is 140. Divide by 4. And we get x equals 35 degrees. Now let's make sure we've answered the question. It says, find the measure of A. A was X. That's what this says. I'm done. All right, and last but not least, exercise 3 is going to get into some quadratics. So I want you to pay attention, but the reason it has an asterisk is we haven't done a lot of quadratics so far, so this one might be a little stretch because you might not remember this stuff from algebra. So just watch me do it and know that on your test for this unit, we're not going to test you on quadratics. They do come up, though, later in the year. So this is a good time to review them before we get to when you really need them. All right, so in example 3, triangle cat CT is extended through T to S. Okay. So it means CT is extended through T to S. And it was triangle cat, so that's A. Angle CAT is x squared minus 3x. Angle CAT, to know where to put that, it goes at the vertex. So angle CAT really goes up here at angle A. That's x squared minus 3x. ACT, that really goes at angle C, is 6x plus 20. And ATS, which means it really goes at T, is 2x minus 5x. Oh, but wait. T has two angles. One there and one there. So to figure out which side it goes, I literally am going to trace it. ATS. Start at A, go through T, end at S. I've drawn this angle right here. So that's where the 2x squared minus 5x is going to go. Okay, now I have the same thing that we had before. 2 on the inside, add up to the 1 on the outside. X squared minus 3x plus 6x plus 20 is 2x squared minus 5x. Ooh, I got an x squared. So one of the things that you might remember from last year is when you have an x squared in an equation, you want to set the equation equal to 0. And you want to set it equal to 0 so that your bigger x squared stay positive. So I'm going to subtract x squared from both sides because there's more of them on the right. So then I have 2x squared, take away an x squared is 1x squared. And then over here, I'm going to combine like terms. Negative 3x plus 6x is 3x. And now I want to set this equal to 0, but I want to leave the x squared where it is. So I'm going to take everything off of this side. All right, so those subtract to 0. Negative 5x minus 3x is negative 8x minus 20. And then again, we're like light years away from geometry now, and we're only in algebra land. In algebra land, when I have a quadratic set equal to 0, one of the strategies for solving it is to factor. So I need to find two numbers that multiply to negative 20 and that add to negative 8. Well, two numbers that multiply to negative 20 and add to negative 8. 1 and 20. Nope, not going to get an 8 there. 2 and 10. Ooh, 2 and 10 can get an 8. If I do a positive 2 and a negative 10, they will multiply to negative 20. And positive 2 minus 10 adds to negative 8. So since this lead coefficient is a 1, those are my factors. Positive 2 and negative 10. And then once you have those two, you set them both equal to 0. X plus 2 equals 0. X minus 10 equals 0. Minus 2. X equals negative 2. Plus 10. X equals positive 10. Whew, that was a lot. And in fact, we're not even done yet. Now I got to go back to the geometry side. It says find X. So this says X is negative 2 or positive 10. Can it be both? I don't know. Let's find out if it can be both and if they both work or if I get some funky negatives going on. So let's plug the 10 in first because a positive 10 feels like a pretty good value. So if I put positive 10 in here, I have 2 times 10 squared minus 5 times 10. That's going to be 2 times 100. So 200 minus 50 is 150. All right, that feels appropriate. And I'm going to plug 10 into here. 6 times 10 plus 20 is 60 plus 20. That's going to be 80. Okay, I can live with that. And then if I plug 10 in here, I have 10 squared minus 3 times 10. That's 100 minus 30. That thing's 70. Okay, I'm feeling pretty good. X equals 10 feels right. What about the -2? Oh my gosh, Mrs. Vibber, so much. All right, I'm going to do this one over here so that we don't have an overlap here. So if I plug -2, I would have -2 squared minus 3 times -2. That's going to be 4 minus -6. 4 minus -6 is 4 plus 6. That's 10. All right, let's do this one. This one's 6x plus 20. 6 times -2 plus 20. Well, that'd be -12 plus 20. That's 8. I mean, these are tiny angles, but they're positive, so I'm okay. And now let's plus that -2 here. 2 times -2 squared minus 5 times -2. That's going to be 2 times 4 is 8. -5 times -2 is positive 10. That'd be 18 degrees. Yeah, those are all positive, so those both work. Now, if you, for the last 4 minutes, have been like, dear God, what is happening right now? That's okay. This was a lot of geometry smashed into algebra, smashed again with geometry. It was a geometry and algebra sandwich. If that's overwhelming to you right now, it's okay. We will get there. I just need you to understand the rule. The algebra can come as we go. All right, and I always end with a terrible joke. So your terrible joke for today is, why did the Scarecrow win an award? Why did the Scarecrow win an award? Because he was outstanding in his field. Outstanding in his field? I know. So I am done now. Work on the checkpoint questions that follow this as well as your homework, and you are good to go. Thanks for watching.